All right, 2.13, this is actually part 3. Here we go.
Previously, we solved inequalities of polynomial and rational functions. To do this, we first found any x-coordinates where the functions had zeros, poles, or vertical asymptotes. Then we used a sign chart to determine intervals where the function was positive and negative. We can solve inequalities involving exponentials and logarithms in the same way, except it is actually much simpler when working with exponential and logarithms, believe it or not.
All right, fantastic. So on this example, we have f of x is equal to this, and we need to figure out when f of x is greater than 0. All right, and so one thing that we always need to be aware of is domain issues. All right, and so what do we know about domain issues of logs? They have to be what? They have to be greater than 0, exactly. So if we're working with this one right here, I would first do a domain as being what? X plus 3 is greater than 0. And so x is greater than what? Negative 3. And so that's going to be where we start our number line when we make our sign chart. Okay, and so from there, we're just going to kind of tuck that away for a sec. And so now we're going to set our function greater than 0. And so now I have log base 10 of x squared minus 4x plus 7 minus log base 3, or log base 10 of x plus 3 is greater than 0. Now, I can't strip away my logs right away, can I? Say no. No. So what's really happening on the left side of my equation? Subtraction, right? And so subtraction is really what? Division. And so now I'd end up having a log of x squared minus 4x plus 7 over x plus 3 is greater than 0. Now, right now it's in logarithmic form. So what form are we going to put it in? Exponential form. And so what's my a? 10. So now I have 10 to the power of 0. What is 10 to the power of 0? 1. And so now I have this x squared minus 4x plus 7 over x plus 3 is greater than 1. Again, how did we get that 1? 10 to the power of 0. Okay? Do what? Yep. All right, and so now, how do we get to our x? We first need to multiply by x plus 3. And so now we're left with x squared minus 4x plus 7 is greater than x plus 3. And so now I want to get my x squareds on, or everything on one side of the equation. And so I personally am going to keep my x squared positive. So now I have x squared, and then how many x's? Minus 5x, and then plus 4 is greater than 0. Now, I've discovered a quadratic. What do we like to do to quadratics? We F them up. All right. And so what does it factor to? X minus 4 and x minus 1. And so now, if I were to set that equal to 0, I get x equals what? 4 and x equals 1. And so this is where I'm going to start making my little number line. So remember this x is greater than negative 3 thing? So this is where it's coming into play. So now I have a negative 3, and I cannot go to the left of negative 3. Again, why can we not go to the left of negative 3? Because it breaks it, okay? It's not in the domain, all right? Okay, that's kind of the additional part of these logarithm things. And then I have 1, and I also have 4. Okay, see how we did that? Cool, let's keep moving. And so now we need to pick something on this interval, negative 3 to 1. So what could we pick? 0, let's do it. And so when we substitute in 0, this will be what? Negative. This will be negative, which makes it a positive. So I have a positive going on there. And so then let's pick something on this interval. 2, sounds great. So this will be negative, this will be positive, which makes it a what? Negative. And then let's pick on something over the year. So like pick what? 5 sounds great. So this will be positive, this will be positive, which makes it a positive. Now let's answer our question. F of x is greater than 0. So I'm looking for my positives. All right. And so when is it positive? From negative 3 to 1 and from 4 to infinity. And there we go. All right, pretty good. Cool, let's keep going. All right, so now we're going to skip to example 6. All right, we're going to skip to example 6. All right, so on this one, I have k of x is equal to that, and I need to figure out when k of x is less than or equal to negative 31. All right, so I'm just going to rewrite what k of x is. And so now I have 1 minus 4 times 2 to the power of x minus 3. It's less than or equal to negative 31. All right, so what's my first step? No, I don't want to do that. I'm going to subtract 1. All right, so I'm going to subtract 1. And so now I'd have negative 4 times 2 to the power of x minus 3 is less than or equal to what? Negative 32. All right. And so now what do? How do I get to my exponential equals a number? I divide by a negative 4, and this is where I want to discuss this part. If I divide by a negative 4, what happens to my inequality? It flips. All right, so we're going back to our Algebra 1 days. And so now I have 2 to the power of x minus 3 is what now? Greater than or equal to 8. Now, on this one, it plays super nice. Could I put it in log form? Sure. However, what also could I do with 8? I could have a base of 2, exactly. And so I'm going to convert it to a base of 2. So now I have 2 to the power of x minus 3 is greater than or equal to 2 to the power of 3. And then what happens to the 2's? They cancel out. And so now I'd have x minus 3 is greater than or equal to 3. And so x would be greater than or equal to 6. How could I put that in interval notation? 6 to positive infinity. Now, do we get to include 6? Yes, so what should we put on it? A bracket. All right.